Hello students, welcome to Dr. B.R.M. Bedkar Open University. As a part of UG first year, first semester microeconomics, we are talking about short run costs. So in the last session we have talked about the table representation, that how we are calculated those theoretically we have seen. So in this particular part you can see how do we calculate how graphs will be represented, right? So if you map with your textbook, you will be able to see the graphs very simple and clear. When it comes to total fixed cost curve, that is horizontally straight line parallel to x-axis. Fixed costs remain constant irrespective of output level, right? Total fixed cost, why it will be remain fixed? Because as we told you, whether you use it or not, it will be added into your cost. Like once you build a building, you buy a equipment or machinery, it will be fixed. So you use those machinery and product more effectively so that the total fixed cost curves will increase. That's where it will be constant. Whether you use it or not, you use more those fixed assets, that the total costs per unit cost will come down. Like for example, if you are using daily only 10 units if you are able to produce, but it has a capacity of 100, the 90 under capacity you are doing. If you use 100 capacity, then your cost per unit will come down. So that's where the machinery and buildings are common, it remains same. So the total fixed cost will be same. TVC curve, we are talking about graphical. We have seen the tables, since graphs we can see in the textbook. So we are seeing TVC curve which starts from its origin. That means in the graph you will see the origin, inverse S shape reflecting the law of variable proportions, rises at increasing the constant then dimensioning rate, right? It is increasing in the constant then dimensioning rate. So the total variable cost, as you variable cost means the factors which can be changed, like we discussed about working capital. So total curve, the TC curve, TFC plus TVC positively slopes inverse S-shaped curve. So that is a vertical distance between TC and TFC equal to TVC. Here your short run average fixed cost curve, rectangular hyperbola, the shape of the slopes we can see rectangular hyperbola, and downward left to right. As output rises, fixed cost spreads over more units. Just now I have explained you. Approaches but never touches the zero, right? Because the fixed cost can be declined, but per unit it definitely includes this. Short run average variable cost, this is a U-shaped graph, falls initially, that is increasing returns, reaches minimum of at optimal output, then rises steeply, which is dimensioning returns. So here that your short run total cost curve is a U-shaped, sum of the short run average fixed cost plus sum of average variable cost. Minimum points occurs in the right of SAVEC, minimum due to continuously falling AFC. So marginal cost curve, short run marginal cost, this is also in U-shaped. First derivative of the TC falls faster than the average total costs, and here the costs of SATC at minimum point from below. So that is where your the short run cost curves which will goes. Now let's understand the key relationships. Both are U-shaped, that is a law of variable proportion, and SATs minimum occurs at the right of SVAVC minimum, that is a short run average cost, variable cost is minimum. Gap between ATC and ABC in the short run is the AFC, which continuously falls. So when ABC rises in the short run, that average total cost may still fall. That average fixed cost in the short run decline offsets ABC rise, right? So beyond a point, rising your short run average variable cost greater than falling the short run average fixed cost, which leads to short run average total cost rises. Now, if you see that the short run average total cost versus short run marginal cost, when SATC falls, short run marginal cost also falls, but SMC falls faster. Average total cost falls, but marginal cost falls faster than the average total cost. When average total cost rises, marginal cost also rises, but SMS rises faster than the ATC. So these are all very important and applied nature whenever you are applying any competitive exams or when it is asked exam, these applications are very important. At the minimum point of your STC, SATC, SMC, that is short run marginal cost equal to average total costs. This reflects the law of averages and marginals relationships. So now look at the long run cost curves. We have talked about short run. So long run average cost curves, this is also, as we discussed, known as envelope curve or planning curve, right? Please remember this point also. Long run average cost curve is known as envelope and planning curve. This is derived from the short run average cost curves of various plant sizes, small a, medium B, large C, right? So LAC is tangent to each ATC curve at relevant plant sizes. That's where you could see that U-shaped curve, which reflects the loss of return to scale. Minimum point M, that is equal to optimal output. That is the, what do you mean by optimal output? That's the least cost which happens. Tangency left of M, suboptimal capacity. Right of M, over optimal capacity. So in the long run marginal cost curve, which is derived from the short run marginal cost curves via points of intersection with the vertical lines drawn from the tangency points of SATC and LAC, that is the long run average cost. The long run marginal cost joins the points F, that is where your LMC is equal to SMC, the G equal to, that is LMC is equal to SMC2, H equal to LMC is equal to SMS3, U-shaped but flatter than the short run marginal cost curve because of all factors are variable in the long run, which we have already discussed. So then what is the relationships of long run average cost curve versus long run marginal cost curve? Similar to the short run average cost and short run marginal relationship, when long run average cost falls, long run marginal cost also falls faster. At point E, that is equilibrium point, LMC, that long run marginal cost, equal to long run average cost, that is LAC. When LAC rises, LMC also rises faster. LAC and LMCs are flatter than their short run counterparts. So in this overall, we learned that in the short run, in the long run cost curves, theoretically, graphically, that how which goes. So I recommend to look at your unit 10, the graphs, with video so that you will be able to understand relatively better, right? Because the graph representation, graphical points are very, very important. Thank you.